So irreversible inhibitors are just that. They bind to the enzyme irreversibly. They're not going to have any effect. Well, the effects that they have on kinetics is pretty straightforward. The enzyme can't do its reactions. It can't perform its functions that it needs to do. But these are useful for determining the specific structures of the active site, or at least for leading us to hints for how the enzymes do their reactions that they do. And there's four types that I need to mention. The first one is group-specific irreversible inhibitors. As their name implies, they are going to react with specific R groups of specific amino acids on the active site of the enzyme. So obviously this can be used to deduce a lot of helpful information about what amino acids are in the structure. What amino acids are in the active site. If I have a group-specific inhibitor that inhibits the enzyme activity and that's designed specifically to bind to, say, I don't know, tyrosine or tryptophan, well, there's probably that in the active site somewhere, right? The other one is affinity labels. Now, whereas with group-specific, this was a non-covalent interaction. With this is a temporary covalent interaction. So they're going to covalently modify the active site. Covalently. So if it's covalent, that means it's probably irreversible, hence the name. The active site. A permanent covalent bond, very stable covalent bond if you could think about it, with one, that's a W by the way, I can write, I'm English, with one amino acid in the active site. This also tells us, just like with group-specific activities, that there's details about the amino acid sequences inside the active site, right? So the other one is known as a suicide inhibitor, and I like calling it that, or mechanical inhibitors. So this tells us a little bit more, not necessarily about the active site itself, but the types of catalysis reactions that are happening here. So for suicide inhibitors, the inhibitor obviously is going to bind to the enzyme, and everything's okay. It's okay until this point. And then, once it proceeds to the next step, once it undergoes catalysis goes on to give it a very reactive, there's an intermediate in this reaction that's very, very, very reactive. And this reactive intermediate is going to form a very strong covalent bond to the active site. Let's say reactive intermediate, this is going to form to the active site. So in this, it's kind of like, what are those, the murder porn movies that ripped off Seven? What are they called? Saw. Like those. It's kind of like a rip-off of that, you know, where he's like, I never kill people. They kill themselves because of a fucked up contraption thing that I put them in. But it's kind of like this with the suicide inhibitors. The enzyme substrates inhibitor complex forms no problem. The enzyme's okay at this point. It's not until the enzyme undergoes catalysis that it undergoes a reaction that it essentially kills themselves. So that's why they're called that. And then you should already know about this, but transition state analogs are really good at inhibiting enzyme activity. They're irreversible. The way they do this is, as you can imagine, they mimic the transition state. Mimics the transition state of your enzyme. So instead of, and it's going to have a higher affinity for that, and so it's going to bind to it, and in doing so, the binding energy is going to be so strong that it's going to form a temporary covalent bond there, and it's not going to be able to move forward or backwards to get out of the spot that it's in, so it's going to be permanently inhibited.